Hey, hi, this is Rohan, and today we are going to talk about nuclear fission and fusion. And both are some interesting topics and fascinating things. Let's take the example of a nuclear fission, which means breaking of an element, heavier elements into smaller elements. Okay, and we use this in to making atomic bombs. Take a unstable element like uranium and you bombard it with electrons. It gets converted into lighter elements, okay, with less mass and more electrons, which can then bombard more uranium. And also it the resulting lighter elements have less mass than the uranium, so the extra mass which is there gets converted into energy and heat, and that's how you get the energy output from a nuclear fission. But also it produces extra electrons which can then be bombarded to more uranium, and the chain keeps on repeating, and we get a process called nuclear fission, which is used in atomic bomb and for producing electricity. But there's a problem with it. The problem is that it creates so much waste, and it is unstable because it keeps on creating new electron. Once it starts, it is highly difficult to control it and contain it. So yeah, that's about it. But now coming back to fusion is something entirely different process. Is It's exact opposite of a nuclear fission. In fission, heavier elements get converted into smaller elements, which is a natural thing. But in fusion, because of pressure and so many other things, uh, probably in heat, uh, lighter elements get combined into heavier elements. But the resulting heavier element is less in mass in the nucleus than the sum of the two lighter elements it has been formed. For example, two hydrogen elements forming helium, the helium has less mass than two hydrogen elements. So what do you get? The extra mass still gets converted into energy, but it is more less than what we get in the nuclear fission. Therefore more energy is released, and this process is called nuclear fusion. But because to combine two lighter elements into higher element, we already required a huge pressure chamber and heat, and already existing in the place, it is highly difficult to create it in a control scenario in earth. We can do it, we do it in hydrogen bombs and so on, but it's a difficult process and therefore can't contain it. So it is even more difficult to create electricity when you compare it with a nuclear fission process. And where do you get this hydrogen fusion creating helium? You get in the core of a star on our sun, and it's a very difficult process. um, Imagine the sun. Our sun is so far away, and the fusion process of creating helium from hydrogen keeps on happening every minute, every second on it. And essentially it is an hydrogen bomb going off every minute. So imagine a hydrogen bomb going on in earth, it would be devastating. Now imagine that multiply by tens and thousands of bombs every minute on the surface of the earth, and that process is going on for millions of years, and it will keep on continuing for even further millions of years, and still it will take another millions of years for the sun's fuel to run out. So imagine the scale of the sun and how much hydrogen is there in the sun, and that would give you a scale of the sun. Despite so many hydrogen fusions happening creating heliums, it will take millions and millions of years for suns to go exhaust, and we might not be even there to witness it. And the fascinating thing is both of these processes are unique, controllable to a certain extent, and we can produce basically enough electricity for the human needs based on these two processes alone. And we have all the raw material, bomb part of it. Yes, it is difficult, it is unstable and so on and so forth, but that is uh, that constraint exists for making bomb, and that constraints exist for making electricity also. but the money, the research, manpower, and time power goes into making bombs. So if you do a quick Google search, you will find out that we have so many hydrogen bombs and nuclear bombs available in our arsenal, but very few electricity generation machine. There exist, but they are limited and in output. Ideally, it should have been giving the output for the whole of humanity, but it requires a different kind of skill set and focus and dedication to do it. When was the first time you encountered this nuclear fission or fusion process? And it might seem uh, like a difficult thing to achieve in your home, but what we can do is we can generate heat by the way of friction, and because of that friction, uh, we can we can transfer the electrons from one element to another, and that can generate enough heat for us to make the bear of it. And we we can just imagine the scale and the depth of it. So that's about it for nuclear fission and fusion. And let's see. What's your favorite thing? Is it nuclear fission or fusion, or do you like a both? Let's start a poll. When you think about the sun and the power it has, the creative fusion to create, combine the lighter elements into higher elements, and we are just observing only one of the sun which directly interacts with earth, the center of our solar system. And now multiply that with millions of stars in our universe, and you will find out that so many fusion and fission things keeps happening in all over the universe, and it keeps on generating heat and power and so on, and the energy keeps on getting dissipated in the universe. So what happens when a star, thus our sun, eventually runs out of the fuel? The fuel is hydrogen, which is keeping it illuminated. What will happen when it runs out of it? It will have all the helium element into it, and either it will get disseminated, it will huge blast, and it will uh, get into smaller pieces, and the energy will be dissipated through the universe. And nuclear fusion, okay, and some another star will born from the ashes of the explosion of the sun, or the sun will implode on its own weight if it is big enough sun, and it will lead to a generation of the black hole, and it will keep on gulping everything which comes into in its interaction. So eventually our nuclear fusion and fission, which gives us the light, which gives us a life on earth, eventually dies out, and eventually it becomes the death flag bearer of the death by becoming a black hole. Sun, which is a life giving element, because we our dependency is on the sunlight to generate food and so on and so things, but it becomes the antithesis of it, black hole, and becomes the bearer of death. So that's about it for today. uh, for me, the nuclear fusion is still on the higher side, because it creates more energy, okay, and if we can contain it and we can produce, make it use for electricity, it can change how we see the world. Okay, so that's it for me today. See you guys, and have a lovely time. Bye.